Today we're going to look at how to measure the off-state capacitance of the MM3100. We'll walk through how we do our open calibration, verify our calibration is good, and measure both the input to output capacitance and the capacitance between channels. So we want to make sure that we're only measuring the capacitance of the device and not of the traces or the socket. So using the socket board makes it easy to take the open calibration because we can just remove the part and then use this to get a good open calibration. So let's do that now. Now we want to make sure that we're only measuring the capacitance of the device and not of any of the rest of the board. So we want to cal out any capacitance we might get from our traces or our socket. It's very easy with the socketed board because we can just make sure there's no part inside and use that to perform an open calibration. So we'll do that now by attaching our cables to the input and output of one of our channels. Once the cables are attached, we can go in and measure our open for our calibration. Now that we have our cables connected, we can do our calibration to get the LCR meter set up to correct for the open. So let's do that now. Go into the menu, go to the correction, select the open, and measure our open socket. Our open correction should be applied now, but of course our measurements are only as good as the calibration. So first we want to verify that everything is calibrated correctly using this board, which we have a 50 femtofarad capacitor soldered on, to make sure that the calibration is correct. So we'll hook this up now. As we can see, with our known value capacitor hooked up, the LCR meter is reading right about 49 femtofarads. This is a good indication that our calibration is good and the measurements that we take of our actual device will be accurate. So now we can put one of our MM3100 devices into the socket and take some actual measurements. So the first measurement we're going to take is the C-off from input to output. So this is the capacitance of the device with the beam open, just looking between the input and output. As you can see, we're sitting right at about 43 femtofarads. Now we're going to take a look at the channel-to-channel off capacitance. So right now we have it hooked up to two adjacent channels, and we can see that the capacitance between those two channels is about 36 femtofarads. As you can see, as the distance between the channels that we're measuring capacitance between increases, the capacitance goes down, in this case to about 6.7 femtofarads. If we were to continue to put more channels between our measurement points, the capacitance would go down even further.